In this video, we're going to talk about how to add and subtract rational expressions. So if I want to add or subtract rational expressions, I must have a common denominator. Once I have a common denominator, we're just going to add the numerators together. The numerators at the top. And always simplify. So what if we don't have a common denominator? This is where we're going to find that least common multiple. And then we may have to multiply one or both fractions by a number to get that least common multiple. So let's just use an example with numbers. Let's say we have 5 over 11 plus 6 over 11. Okay, well, we already have a common denominator, so all we have to do is add the numerators. That's going to give us 11 over 11, which is really the same thing as a whole. The question becomes, what happens when I have like 2 over 5 plus 3 over 10. And I need to add those. Now we do not have a common denominator. So we got to find one. We got to figure out what is the smallest number that both 5 and 10 go into. That's called the least common multiple. So in this case, the smallest thing that both go into would be 10. So that first fraction, I need a 10 down here. So what do I multiply by? I'm going to multiply by 2. What I do to the bottom of the fraction, I got to do to the top. Math is always fair. So then we would multiply. So that's really the same thing as 4 over 10 plus 3 over 10. Now this one was nice. We didn't have to do anything to that second fraction. So that's going to give me a total of 7 over 10. Okay, sometimes you got to multiply both numbers by something. Let's look at an example. Let's say we have 2 over 5 plus 3 over 8. So we got to ask, what's the smallest number that both 5 and 8 go into? And it looks like it's going to be 40. So then we ask, how do we get to 40? Well, we're going to multiply by that 5 by 8. What I do to the bottom, I got to do to the top. And then we're going to multiply this 8 by 5. Again, what I do to the bottom, I do to the top. So now I have 16 over 40 plus 15 over 40, which is 31 over 40. So the same concept's going to apply when we have rational expressions. So the first one, we have 3x over x plus 4 plus 5 over x plus 4. And we have the same denominators, so we're just going to add the numerators. We have 3x plus 5, which is just 3x plus 5, and that's over x plus 4. Okay, in the next example, we have 2 over x plus 3 over x plus 5. So notice we do not have the same denominator. So we're going to think about that least common multiple. So I have x and I have x plus 5. And remember we talked about the neighbors competing with their garages and their equipment from Lowe's. It does not matter which neighbor I start with. If I start with x and I look in my neighbor's garage, we already have an x. In the garage, the neighbor has an x plus 5. So we're going to run out to the algebra store and we're going to buy an x plus 5. There's our least common multiple. So then the question becomes, how do I turn each denominator into x times x plus 5? So I'm starting with 2 over x, and then I'm adding 3 over x plus 5. So if I want to turn this x into x times x plus 5, I need to multiply by x plus 5. What I do to the bottom, I got to do to the top. Same thing here. I 3 over x plus 5. So it's missing the x, so I'm going to multiply the top and the bottom both by x. So that's going to leave me with x plus 5 times 2. So I'm going to distribute 2x plus 10 plus 3 times x, which is 3x. All that's over x times x plus 5. And then we're going to simplify. I have a 2x plus 3x, which is a 5x, plus 10, all over x times x plus 5. So there's my final answer. Okay, that next one, I have x plus 3 over x minus 2 minus 4 over x plus 2 plus x squared minus 4. Oh, plus 5x minus 1 over x squared minus 4. So I'm looking at the denominators. I have x minus 2, x plus 2, and then x squared minus 4, which is x plus 2, x minus 2. Trying to find that least common multiple again. It doesn't matter where I start. I'm going to start with that x minus 2. So I'm going to start with that group. If I look in the neighbor, that first neighbor has an x plus 2, so he's going to want 1. And then if I look in the second neighbor, I now have everything that that second neighbor has. So my least common multiple will be x minus 2 times x plus 2. So I'm going to recopy my problem here. Leaving some space. And I'm going to ask that first fraction, the denominator is x minus 2. So what is it missing from that least common multiple? It's missing the x plus 2. So I'm going to multiply by x plus 2, but what I do to the bottom, I got to do to the top. The second fraction has a denominator of x plus 2. So it's missing the x minus 2. We'll multiply the top and bottom by the x minus 2. And then if I look at that other fraction, the last one, it already has x plus 2 and x minus 2, so I don't really need to do anything to that. I can just leave it. Remember, there's an understood parentheses around the tops and the bottoms of a fraction. So now I've got that common denominator, so I'm going to squish those numerators together. So I have x plus 2 times x plus 3 minus 4 times x minus 2 plus 5x minus 1. All of that's over x plus 2, x minus 2. So now we need to simplify the top. So we're going to do some FOILing. We're going to have x squared plus 3x plus 2x, which is a plus 5x. And then the last is plus 6. Then we're going to distribute the negative 4. So negative 4 times x is a negative 4x. Negative 4 times a negative 2 is a positive 8. Plus, and there's an understood 1 here. So 1 times 5x is a positive 5x. 1 times a negative 1 is a negative 1 over x plus 2, x minus 2. And then we're going to simplify. So I've got x squared, combining like terms, 5x minus 4x plus 5x is a 6 times x. 6 plus 8 minus 1 is a 13. All of that's over the x plus 2, x minus 2. This guy is not going to factor, so there's my final answer. It's going to be x squared plus 6x plus 13 over x plus 2, x minus 2. If I want to think about restrictions here, what kind of things can I not plug in? I can't plug in a 2 or a negative 2. So x cannot be equal to 2 or negative 2.